Hello, in this video we are going to be talking about collisions in Pygame, and specifically we are going to be making this kind of project in the end. But before we get into this specific thing, we will talk a lot about collision theory in Pygame and how to avoid problems, specifically these kind of problems that can get very annoying with collisions. Before we get into any kind of code, let's first talk about the theory of collisions in Pygame. And the most important thing you have to be aware of is that you always need a rectangle to check for collisions. This could either mean that you draw inside of a rectangle and move that drawing, or that you have an image and you draw a rectangle around it. But in both cases, you will always move the rectangle and also check if the rectangle is colliding with another rectangle. And the easiest way to check if two rectangles have been colliding is with colliderect. And this one is a very easy function. It just takes two rectangles and then it returns either true or false if they have been colliding or not. But the problem with colliderect is that it doesn't tell you where the two rectangles are colliding. So if you want to create some kind of bounce mechanic where you need to know the side of the collision, this one would not be ideal. But that being said, you can work with it quite a bit. And when we create a project later on, I am going to use colliderect quite a bit. But if you want to check a specific side of the collision, you would need collide point. And what collide point does is that it checks if 2 points of one rectangle are colliding with another rectangle. And there are quite a few points you can check on a rectangle. You can see all of them on the screen right now. And using collide point can be very powerful, but it can also be very easily creating bugs in your code. And let's talk a couple of approaches that are not ideal. Number one, you want to use the midpoints of the rectangle. So you have two rectangles and you're going to check with mid left, mid right, mid top and mid bottom if either of these points have collided with the other rectangle. And from that you get the information which side has collided, which would work reasonably well. But here's the problem with it. You only check 4 specific points on the rectangle. If the corner of this rectangle overlaps with the other rectangle, this one would not be checked, which can look very silly in the game and it might even be a game-breaking bug. So what you have to be aware of that if you only check the middle points, the corners are not covered at all. Which brings us to the second point, that on this rectangle you don't check the midpoints now, instead you check the corner points. So you check top left, top right, bottom left and bottom right. But here's the problem with this approach. Let's say the bottom right of one of your rectangles is colliding with the other rectangle. This wouldn't actually tell you which side has been colliding with the rectangle, because bottom right doesn't tell you if it's on the right or on the bottom. So ultimately this approach also doesn't help, because there's confusion about which side is actually colliding. And that brings us to another approach, and that is to combine the first and the second approach. So you check 8 different points on the rectangle, and you only do something like, if the bottom right and the midpoint of the bottom have collided, then you know a collision on the bottom of this rectangle has occurred. Which first of all would be a lot of typing and quite a bit of checking. And second of all, this might be a better approach, but it would still have quite a few problems. And especially it would struggle with very small objects. So let's say you try to collide with a very small object that might slip in between the bottom right and the mid bottom point. In this case, the small rectangle might just disappear in your rectangle you want to check and no collision would be triggered. And also, if only a part of your rectangle collides with another rectangle, so it only touches a corner of it, then a collision would also not be triggered. So all of this is a lot of typing and not very reliable. So instead, here's a much better approach. And that actually uses colliderect, even though it seems a bit counterintuitive. But let me explain the logic. We still have our two rectangles, and the first thing we do is we use colliderect to check if there has been any collision. If that is the case, we do another calculation for each side of the rectangle we collide with. And let me give an example for one of these calculations. Let's say we want to check if the top was collided with. And all we really need to calculate is if the bottom of one rectangle is equal to the top of the other rectangle. So we just subtract one from the other. And if that number is either 0 or really close to 0, then we know a collision from the top has occurred, because those two would have the same height, which couldn't be the case if any other collision has occurred. And then we do the same kind of calculation for each of the sides. So for example, for the right side, if any collision has occurred, we check the right side of one rectangle and the left side of the other rectangle, and if the subtraction of both of these is somewhere close to 0, we know that the collision on that side has occurred, because this kind of calculation would only work for this particular side. And this approach has a couple of advantages. First of all, it's very easy to program and it only requires a couple of lines of code. And second of all, it's also much more reliable. So the size of these rectangles doesn't really matter because we always check if they have been overlapping in any way whatsoever. and there's also much less confusion about which sides have been colliding. So let's implement this approach. So here again, I have a very basic setup for Pygame, and if you're completely new to Pygame, check out another tutorial I made that explains all of this. But basically, here we create our main display surface, and I have two variables, screen width and screen height, and each of them are 800 pixels. And then in our main game loop, we only check if the game is being closed, then we fill the screen with a fairly dark color, and then we just draw the entire thing at the frame rate of 60 frames per second. So if I run this, we can see a dark screen essentially that can do anything except being closed. Cool. Now I want to create two rectangles. So the first one I'm going to call moving rect, and to create a rectangle we need pygame.rect, and I'm going to give it the dimension of 350. So this is the x and the y position of the rectangle. And now I need to give it a dimension, and I'm just going to give it 100 and 100, which basically means that it is 100 pixels wide and 100 pixels high. And since we're going to move this rectangle, I am also going to give it an x and a y speed. So I have x speed and y speed, and I'm going to put 5 and 4. I'm going to implement those in just a second. Next up, I want to have another rectangle that I'm going to call otherrect because I couldn't think of a better name. And this one we create in just the same way with pygame.rect, and I'm going to put this at 300, 600, and it is 200 pixels wide and 100 pixels wide. So we place it 300 pixels from the left, 600 pixels from the top, it is 200 pixels wide and 100 pixels high. And I'm also going to give this a speed. Let's call it other speed. And this is going to be 2. It's supposed to be moving very slowly. But we're not going to use this one for quite a while. But I guess it's fair enough to just have it for now. And right now, these rectangles are not on our screen. So if we run this game, we wouldn't be able to see them because we haven't drawn them yet. Which we can do very easily with pygame.draw.rect. And this one needs 3 pieces of information. The first one is the surface to draw on, which in my case is green, so the main display surface. Then we need a color. I'm going to go with 255, 255, and 255, so white. And then we need the actual rectangle we want to draw. And in my case, this would be moving rect. So this one would draw the first rectangle. And it's right in the middle, and now we can see it. And now I also want to draw the second rectangle, so I just copy this line. And I'm going to give it a slightly different color. So I make this 255, 0, and 0, so we only have the red information. And now I check this to otherrect, and now we should be able to see both rectangles. Exactly. But they're not moving right now. And to implement all of that is going to require quite a bit of code. And to keep our main game loop a bit more simple, I'm going to put all of this into a function. And I'm going to call it bouncing rect. And I call that inside of the main game loop. And then all the drawing and moving happens inside of this one. So at the top, I define a bouncing rect function. And for now, I just draw both of the rectangles inside of it. So if I run the code now, this should look exactly the same, and yeah, it does. So with that one done, let's first move our moving rectangle. And we worry about the other rectangle and collisions between them in just a bit. The first one we need is moving rect.x, and I want to add the x speed to it. And then I want to do the same thing with the y position, moving rect.y, and plus equals y speed. And if I run this now, we would have a moving rectangle. So that's a good start. So what basically happens here is that we move the x and the y point. And if we move any point on a rectangle, we always move the entire rectangle. So all the points on the rectangle stay relative to each other. And if you move one of them, you move all of them. But the problem here right now is that the rectangle very easily moves outside of the screen. So we have to implement some kind of code that the rectangle bounces around the borders of the screen, which we can do quite easily. And what I want to do, let me add a comment. This is collision with screen borders. And the logic here is actually quite simple. All we need to check is if the right side of the rectangle is on the right side of the screen, or if the left side of the rectangle is on the left side of the screen, and the same for the top and the bottom. And we can do that quite easily. So if moving rect.right is greater equal than our screen width, or moving rect.left is smaller or equal than 0. So this one checks if the left or the right of the rectangle has been colliding with the left or the right border of the screen. And once we have that, all we need to do is to change x speed and multiply it by -1. And once we have that one, we can copy the entire thing. And now I want to check the bottom of the rectangle, if this one has been colliding with the screen height, and the moving rect top, if this one has been smaller or equal to 0. And if that's the case, I want to change the y speed. If we were to run this kind of code, we would get an error. And let me demonstrate. Exactly, and Python is going to tell us that local vary x speed has been referenced before assignment. Basically what happens here is that we try to change a global variable from a local scope, which doesn't work. So we have to declare global x speed and y speed. And check out scopes and Python if you want to have more information on this. But if I run this now we have collisions with the sides of the screen. And that one works actually fairly well. But with the red rectangle, we don't have any collisions just yet. So let's start to implement this. And let me add a comment first. That is collision with rect. And here's the logic I explained earlier. So the first thing is if moving rect.collide rect, and we want to check the other rect. And we can already try this, and let me just print collision. So now if this rectangle is colliding with the other rectangle, Python is going to print collision. So let's try this. And yeah, there we can see collision. So we can already tell that this function triggers well. But obviously it doesn't tell us which side has been colliding. But we can add that one quite easily. And let me start with the top to explain logic here. That if other rect.top minus moving rect.bottom is equal to 0. And if that's the case, we want to change y speed and multiply it by -1. So essentially what happens here is that we first check if any collision has occurred, and then we check if the top of the other rectangle minus the bottom of the moving rectangle is equal to 0, which can only really happen if the rectangle collides from the top. So if this is true, we know that the collision has happened on the top. However, there's one little problem with that one, that this 0 is a little bit too restrictive, because the pixels can move quite fast, and it's not always the case it's going to be exactly 0. Sometimes the rectangles are going to overlap a tiny bit by, let's say, 2 or 3 pixels. So what we need is a collision tolerance, and I'm going to put this at 10. And now here we have collision tolerance. So what we now check if the top of one rectangle minus the bottom of the other rectangle is smaller than 10. And there's one more change we have to make. This number has to be absolute. And let me explain why we need the absolute value, because this one is really important. And here's an example why this matters. Let's say the other rectangle and our moving rectangle collide at point 600. So at the right side of the other rectangle is something like 600, and the left side of our moving rectangle is 602. If you subtract these two, you end up with -2 and you have a collision here. So this one is fine. But our formula checks all the 4 different sides. So it would also check the left side of the other rectangle, and this one would be 400. And if we subtract 602 from 400, we would end up with -202, which would also be smaller than 10. So if we don't take the absolute value, both of these if statements would trigger, which obviously we don't want. But if we take the absolute value, 400 minus 602 would be 202, and the collision would not be triggered. So this is why we need absolute values here. But alright, now we have one side of the rectangle. And what is left to do now is to copy this thing a couple of times. So now I want this rect.bottom and moving rect.top. And then the rest can stay the same. And now I need to do the same thing with the right and the left. And if that's the case, I want to change the X speed. And for the final one, I just need to check if left and right. And that's the basic logic to create collisions. So if I run this now, this should theoretically be working unless I made a mistake. Nope, looks good. And let's try it another time. Yeah, this also looks good. And yeah, this one works quite well. So here, in a couple of lines of code, you have a fairly reliable collision mechanic. But the problem is, if we start to move the second rectangle, this one is going to break a little bit and we have to have some extra code to make this work. And let's implement this first. For now, I just want to move the second rectangle. And let me put this on top here. So moving the other rectangle. And all we need here is other rect.y plus equal other speed. And if other rect.top is smaller or equal than 0, or other rect.bottom is greater or equal than screen height. And if that's the case, other speed is going to be multiplied with -1. And then in global, I also need to declare other speed a global variable. So basically what happens here is that we take the other rect and we move the y point with the other speed. So in this case, that is 2 all the way down here. And if this other rect either collides with the top of the screen or the bottom of the screen, then we change the direction. And let's run this now and see what happens. And let's wait for the first collision. The side does work, but I think now it collides with the bottom. There we go. So this one somehow doesn't work. And I think there's them again. Nope, not here. But yeah, I don't want to wait too long. But the problem here is that if the top and the bottom of these two rectangles collide, then we get a problem. So here it happens again, and now the entire thing crashes entirely. And let me explain what happens here. And the best way to explain the problem is to use different frames, and then we talk about what happens specifically on each frame. So on the first frame, we have an overlap or a collision of the two rectangles, and our moving rectangle tries to adjust for that collision, so it moves in the other direction. So now they are moving in the same direction. However, on the next frame, you might still have an overlap, because our other rectangle might be moving by 2 pixels, and our moving rectangle I think moved by 4 pixels. So if the original overlap was 10 pixels, then they would still be overlapping on the next frame. And if they're still overlapping, our moving rectangle would still register a collision and change the direction again. And then this would happen every frame, because on every frame the two are overlapping or colliding. Which obviously we don't want. But we can fix that fairly easily. All we need to do is check the direction of each rectangle, so that we only trigger a collision at the top if both are colliding at this point and the moving rectangle is moving downwards. And if it's moving upwards, we don't trigger a collision. And then we do a similar kind of logic for each of the sides. And all we need to add is and y speed is greater than 0. And this would already fix the entire line here. And let me explain what happens. That this line here is the same as usual. But now we only check if y speed is greater than 0, which basically means that the rectangle is moving downwards. So this entire line would now only trigger if the rectangle is moving downwards. So let me copy this thing to the other lines. So now we check the collision from the bottom. So the moving rectangle has to move upwards. And for left and right, now we need x speed. And in this one here, we check if the left of the moving rectangle has collided with the right. So the moving rectangle has to move to the right, so x speed has to be greater than 0. And for the final one, we just need x speed, and this time it has to be greater than. So this time the rectangle is moving to the right. And that's basically it. If I run the code now, all of this should be working fairly reliably. And I could have planned all of this a bit better to have a bit more top and bottom collisions, but now they're colliding and this one works perfectly fine. And again, you have a fairly reliable collision mechanic that works even with moving rectangles. And yeah, that's basically it. I hope that was helpful and I will see you around.